There is a book at Yale University that nobody can read. Its pages are filled with plants that do not quite exist, circular maps that lead nowhere, naked figures bathing in green liquid, and thousands of words written in an alphabet found in no other surviving document. The parchment is medieval. The ink behaves like ordinary medieval ink. Someone spent months, perhaps years, writing the text by hand. Yet after more than a century of attention from linguists, historians, cryptographers, and codebreakers, no proposed translation has survived independent examination. That last part matters. People claim to have solved this book every few years. The headlines arrive first. The proof never follows. The manuscript has outlived every confident answer. So tonight, we are not going to decode it. We are going to ask a more useful question. What can this object tell us before we pretend to understand a single word? The book is known as Voynich MS 408, or more commonly, the Voynich Manuscript. It is kept in Yale's Voynich Rare Book and Manuscript Library. Calling it a book almost makes it sound ordinary. It is a complicated bundle of parchment leaves, foldouts, and missing pages. Some diagrams open far beyond the normal edge of the volume. Folio numbers were added later. The binding is not the one the original maker produced. What survives is still substantial. There are more than 200 pages, although the original volume had more. The text contains roughly 38,000 word-like groups. They are written from left to right, arranged in lines and paragraphs, and interrupted by drawings. The writing looks practiced. Letters join smoothly. Corrections are uncommon. Whoever held the quill did not seem to be inventing every mark one at a time. That does not prove the text has meaning. A skilled person can produce convincing nonsense. But it tells us that the manuscript was planned, not scribbled during a single eccentric afternoon. For years, theories about the manuscript depended on whoever a researcher wanted its author to be. Roger Bacon, Leonardo da Vinci, John Dee, and several less famous candidates were pushed into the story. Then 4 pieces of parchment were tested by radiocarbon analysis at the University of Arizona. The samples placed the animal skin between 1404 and 1438 with a probability of about 95%. Radiocarbon dating does not date the ink. It dates the skin. In theory, somebody could have stored blank parchment and written on it much later. In practice, parchment was expensive, and 4 samples from different parts of the volume fell within the same narrow medieval range. The result destroyed some famous theories. Leonardo was born in 1452. John Dee belonged to the following century. Roger Bacon had died long before the goats used for these pages were born. Chemical examination found common historical materials rather than modern pigments planted to fool a laboratory. The evidence does not identify the author, but it makes a 20th century forgery extraordinarily difficult to defend. The book is an old mystery. That much is real. The manuscript changes character as its pages turn. The first and largest section resembles a herbal. One plant fills most of each page, with text wrapped around its roots and leaves. Some drawings contain pieces that look familiar. A leaf may resemble ivy. A root may resemble a human organ. Then the pieces are joined into a plant that no botanist can identify with confidence. The next section moves into circles, stars, and zodiac-like figures. Several signs resemble familiar European astrology, but the arrangement is unusual. Human figures appear around the margins, each connected to stars or labels. Then the book becomes stranger. Small naked women stand inside pools, tubes, and vessels filled with green or blue washes. Older cataloguers called this the balneological section, because it resembles medieval writing about baths and medicine. That label describes the pictures. It does not translate them. Large fold-out pages contain cosmological wheels and a famous diagram made from 9 connected circles. It has been read as a map, a group of cities, a journey through the body, or a picture of the cosmos. None of those readings can be proven from the text beside it. Later pages show jars, roots, and fragments of plants. The final section is mostly writing. Short entries are marked by star-like symbols, which is why people often call them recipes. Herbal, astronomical, biological, pharmaceutical, recipes. These names are useful filing labels, not solved chapter titles, and researchers call the script Voynich. That name sounds like a language, but it only means the marks found in this manuscript. The alphabet depends on how the marks are counted. Some may be separate letters. Others may be ligatures made from 2 strokes. A few tall symbols, nicknamed gallows characters, often appear near the beginnings of lines or paragraphs. Words behave oddly. Certain symbols prefer the start of a word. Others cluster at the end. Similar words often appear close together, changing by only 1 character. Some forms are common in one part of the manuscript and rare in another. 2 broad textual varieties are usually called Courier A and Courier B, after the researcher Prescott Currier. The difference may indicate 2 languages, 2 dialects, 2 encoding systems, or simply different scribes and subject matter. Statistical patterns are one reason the text refuses to die as a hoax. Voynichese is not random in the simple sense. Word frequencies and repetitions have structure. Yet structure alone does not prove language. A set of mechanical rules can also generate patterned nonsense. The uncomfortable answer is that both sides can point to real evidence. The manuscript's medieval origin is supported by its materials. Its early ownership is harder to follow. A faded signature links it to Jacobus Horsicki de Tepanek, a pharmacist and courtier connected with Holy Roman Emperor Rudolph II. A later account says Rudolph bought the book for 600 gold ducats and believed it had been written by Roger Bacon. Yale treats the Roger Bacon link as speculation. By the 17th century, the manuscript belonged to the Prague alchemist Georg Barisch. He could not read it either. Barisch sent copied characters to the Jesuit scholar Athanasius Kircher, hoping the famous interpreter of Egyptian hieroglyphs could help. Kircher never produced a solution. After Barisch died, the book passed to Johannes Marcus Marci. In 1666, Marci sent it to Kircher with a letter. That letter survives with the manuscript and provides one of the strongest points in its history. Then the trail fades. The volume remained in Jesuit collections until the early 20th century. In 1912, rare book dealer Wilfrid Voynich acquired the manuscript from a Jesuit collection near Rome. He understood immediately that an unreadable illustrated codex could become the centerpiece of a career. Voynich promoted the idea that Roger Bacon had written it. If true, the manuscript would have been a hidden work by one of medieval Europe's most celebrated thinkers. The claim attracted scholars, newspapers, and codebreakers. It also attached Voynich's name to a book he had not created and could not read. After his death, ownership passed through his wife Ethel, her friend Anne Nill, and bookseller Hans-Peter Kraus. Kraus tried to sell the manuscript but found no buyer at his price. In 1969, he donated it to Yale. The book finally stopped traveling. The theories did not. William Friedman, one of the most important American cryptographers of the 20th century, studied the manuscript with a team. Friedman had helped break sophisticated military codes. Voynich resisted him. That failure is often exaggerated. It does not prove that the text cannot be decoded. Cryptanalysis works best when researchers know something about the system, the language, or the context. Here, almost every starting assumption is uncertain. A simple substitution cipher should reveal patterns that point toward a known language. the manuscript does not yield so easily. A more complicated system could hide those patterns, but it would also need to be usable by a 15th century writer across hundreds of pages. Abbreviations could explain some of the density. Medieval medical and alchemical texts used them heavily. A constructed language is possible. So is a lost natural language written in an invented alphabet. Every extra layer makes a theory harder to disprove. It also makes it less useful. The Voynich Manuscript has supposedly been Latin, Hebrew, Arabic, Turkish, Old Mexican, a Romance language, and several languages known only to the person proposing the translation. The usual method is easy to recognize. A researcher chooses a set of sound values, expands symbols into abbreviations, rearranges letters when necessary, then produces a sentence that seems to match the picture. Another researcher cannot repeat the method on a different page without changing the rules. That is not a decipherment. It is interpretation with too many escape routes. A real solution must work beyond one attractive phrase. It should explain the script consistently, translate long passages, account for grammar and repetition, and allow other specialists to obtain the same result. No published claim has cleared that bar. Modern machine learning has not changed the standard. A computer can find resemblance between Voyniches and many languages if the researcher makes enough choices before the comparison begins. Software can rank hypotheses. It cannot rescue a hypothesis that has no reproducible translation. The hoax theory has one great advantage. It explains why nobody can read the book. Perhaps someone created an impressive object to sell to a wealthy collector. Rudolf II had an interest in rare, magical, and unusual works. 600 ducats would have been a powerful motive. But producing the manuscript was not cheap. The maker needed a large supply of parchment, pigments, time, and enough discipline to maintain the script's internal habits across hundreds of pages. The illustrations also shift through recognizable categories rather than wandering without any order. None of that rules out fraud. Elaborate frauds exist because elaborate frauds can be profitable. The harder question is how the text was generated. Pure improvisation tends to drift. Copying and altering nearby words could produce local similarities. Tables, dice, cards, or other manual procedures could create consistent frequencies without encoding a readable message. In 2025, a proposed hand-operated cipher called Naibe showed that medieval tools could generate text with several Voynich-like statistical properties. It did not decode the manuscript, and its creator did not claim that it did. The experiment simply narrowed one old argument. Patterned text can be manufactured without modern machinery. Meaningful language and structured invention remain on the table. The plants invite identification because they look almost familiar. That may be the trap. Medieval herbals were copied from older copies. Plants became distorted as one artist repeated another artist's errors. A manuscript might combine the useful part of one plant with the symbolic part of another. Roots could be drawn to resemble animals, tools, or parts of the body. The bathing figures may belong to medicine, reproduction, astrology, or an allegorical system we no longer recognize. The tubes resemble plumbing to modern eyes, but a medieval reader might have seen vessels, organs, channels, or something less literal. Pictures can constrain a theory. They cannot supply a translation by themselves. If a proposed reading says a page describes a sunflower, a matching yellow flower is not enough. Sunflowers reached Europe after contact with the Americas, so the identification would collide with the parchment date unless the drawing or writing were added later. The manuscript is full of these tempting near matches. Each one feels like a door, most open into another room with no exit. We know that the parchment came from animals living in the early 15th century. We know the book was written and illustrated by hand with materials compatible with a historical manuscript. We know its script follows rules. We know several sections use different vocabularies or writing habits. We know that people in 17th century Prague already found it unreadable. We know Marcy sent it to Kircher in 1666. We know Wilfrid Voynich recovered it in 1912, and that Yale has preserved it since 1969. We do not know the author. We do not know the language. We do not know whether the text is encrypted, abbreviated, constructed, or meaningless. We cannot even be certain that every part of the book was made at the same moment. That boundary is not disappointing. It is the shape of the case. The Voynich manuscript does not survive because it contains the most complicated code in history. We do not know whether it contains a code at all. It survives because the physical book keeps refusing our easiest stories. It is too old for a modern forgery, too structured for casual scribbling, too inconsistent for a simple cipher, too expensive to dismiss as a joke without explaining the effort behind it. Someone knew what these pages were for. Perhaps the text records medicine in a private notation. Perhaps it hides ordinary language behind a method that lost its key. Perhaps the words were designed to look meaningful to a wealthy buyer. Each possibility solves one part and leaves another exposed. 6 centuries later, the safest answer is still the least satisfying one. We have the book. We have every visible mark. We can place the parchment in time and follow the manuscript through part of Europe. Yet the mind that organized it remains out of reach. I am Archivist Nox. This case remains unread.